So the next logarithmic equation that we will solve is an equation that involves the square of a logarithm. And this is an example. So if we look into this logarithm, you see that the logarithm of x to the base 10 is being squared. So this is what I mean by the equation involves the square of a logarithm. This logarithm and this logarithm may appear similar, but they are totally different. So what's the difference between these two? If you notice here, what we are squaring is the logarithm of x to the base 10. While here, what we are squaring is only x. And we are getting the logarithm of x squared to the base 10. That's why they are different, although they may appear to be similar. So in other words, when you say logarithm of x to the base 10 squared, this is what we are doing. We are multiplying the logarithm of x to the base 10 to itself. That's what it means. While the other one, which is the logarithm of x squared to the base 10, can be written as 2 logarithm of x to the base 10. 2 times the logarithm of x to the base 10 by power law. Which means we have 2 logarithm of x to the base 10, but instead of multiplying, we are adding them. So look closely at this. 2 logarithm. So this mean this, while this mean this, addition. Okay. So now, how do we solve equations that involve the square of a logarithm? By using substitution. Let's use the variable a to represent the logarithm of x to the base 10. So we will substitute a to this logarithm. So the original equation will now become a squared for this minus, so this is written as 2 times the logarithm of x to the base 10, which means that will be 2a equal to 3. And what can you say about the result? After substitution, we got a quadratic equation in terms of a, not in terms of x. Okay. Which means we solve this quadratic equation so we can get the value of a. So how do we solve? So here, I will be using factorization to solve the quadratic equation in terms of a. So the factors are a minus 3 and a plus 1 equal to 0. Correct. Okay. So the values of a are negative 1 and 3. So if we go back to the question, we are asked to solve we are asked to solve the logarithmic equation, which is in terms of x. So the value that we are finding is the value of x, not the value of a. That's why we do not stop here. But we will use these values of a to find x because a is the logarithm of x to the base 10. That means the logarithm of x to the base 10 has 2 values. Negative 1 and 3 equal to 3. Okay, so how do we now solve for x? In this case, we change the logarithm to exponential form. Convert it to exponential form. So, the base is 10, the power is -1, and the answer is x. Same for the other result. Base of 10, power of 3, equal to x. So, x has two values. 10 to the -1 will be 1/10, while 10 cube is 1,000. Are both logarithms valid? So, by checking, by substitution, so if I use 1/10, this logarithm is valid. Okay, this logarithm also, which is equal to this, for 1/10, is valid. So, x equals to 1/10 is accepted. How about 1,000? So, if I substitute 1,000 here, which is equal to this, okay, the logarithm is valid. If I substitute 1,000 to this logarithm, which is equal to this, the logarithm is also valid. Therefore, we have two solutions. So, how did we solve this logarithmic equation again that involves the square of a logarithm? By substitution. We substituted a for the logarithm of x to the base 10. We got a quadratic equation in terms of a. We solve for a, then we solve for x.